Hello everyone, welcome to WAYN Games. Today we will learn how to capture inputs and create a tower entity at the selected position. To that end, we will use the new input system and .physics package. We will also learn about system ordering and entity singletons. You can get the Tower Defense Starter project on GitHub linked in the description below. And if you want to know how we made this starter project, you can check out the previous episodes in the series. Let's start by opening the package manager to import the physics and input packages. Restart the editor for the new input package to take effect. If you are not familiar with it, the new input system allows to define action maps. These action maps abstract the device used by the user. These greatly reduce the code complexity, making input action agnostic to the device used, and greatly improve support for various devices such as gamepad, mouse and keyboard, or touchscreen. For our tutorial, I am not going to make a full action map since we only have a single action. If you want more details about the input system, let me know in the comments below. Okay, let's make a new mono behavior that will capture our input and pass it on to the entity simulation. For that input manager, we will need an input action and a reference to the camera. In the enable method, we can subscribe to the action. We have three options: started, performed, or cancelled. If we take the example of a button press, started will be triggered when you first press the button. Perform will be triggered for as long as you keep the button pressed. And cancelled will be triggered when you release the button. I will use the start method for our tower to be created as soon as the player presses the button. Subscribe to the input action.started callback with a new method. Enable the action and initialize the camera to the main camera if it's not set in the editor. It's also a good practice to do some cleanup when the input manager is disabled. So in the onDisabled method, deregister the callback and disable the input action. Now in the callback method, we want to read the input from the context and use the camera to compute the position of the cursor in the game environment. We start by reading the input from the context as a vector2. This represents the screen position in pixel where the user clicked. We can then use the screenPointToRay method from the camera to get a ray starting at the camera position, and the getPoint method of the ray with the camera far clip plane distance to get the position of the input in the world. We can log it to check if it works as expected. In Unity, we need to do some setup. Create an empty game object and add your input manager script to it. Assign the camera, and for the input action, we will use a binding with one modifier. This allows us to define an input that will be triggered only if the modifier input is also triggered. In our case, we want to get the mouse position only if the left click is triggered. Set the action modifier to the mouse left click control, and the binding to the mouse position. If we wanted to support mobile devices, we could add another action and set the primary touch tap on the modifier and primary touch position on the binding. No other changes are needed to support multiple devices thanks to the new input system. OK, now enter play mode and click anywhere in the game window. You should see some coordinates appear in the console. That's all we need for the input setup. Let's get to the meat of the video, how to use the physics system to place a tower on our terrain. Now, the physics simulation happens in the ECS world. You can see that in the Systems windows under Fixed Step Simulation System Group. That means we'll need to get our input from the input manager into the ECS world. I want to use a different approach than in the last video. After all, my goal is to show you what tools are at your disposal to make your games. So why not make the entity from the game object instead of making the game object from the entity like last time? Create a new plane in the subscene and place it to your liking. And hit the like button while you're at it. Thank you. In the onEnable method of the input manager, we can add a private reference to an entity to convey our input to ECS. I'm using the world to access the entity manager that will perform all operations on the entity, creation and destruction, as well as adding, removing, or setting component data. Last time I referenced directly the entity manager, but this led to some errors when exiting play mode, so it's better to use the world reference instead of the entity manager. To get it in a mono behavior, we can use the world static reference. Then we can use the entity manager to create a completely empty entity. Unlike the game object empty, this entity truly is empty. It doesn't even have a position in the world. Then, to bring our data into ECS, we will need a component. I'm going to use a buffer type component because it will allow me to simplify the processing of the input, as you will see in a moment. To get the position in the world, we will need to perform a raycast using the ECS physics system. This requires a raycast input. On our component, add a raycast input field. And when the action is performed, add the input to the buffer. For the filter, you can use the default collision filter, which will allow us to cast against every collision layers. Finally, don't forget to destroy the entity if the input manager is disabled. You can now go back to Unity and see that we have the buffer populated whenever we click in the game view. Now that the data is available to us, we can make a system to perform the raycast and get the world position. Making system by hand is a bit tedious, so to help you out, I made some template scripts. All you need to do is get them from our GitHub repository in the description and paste the editor folder into your asset folder. Then you'll get access to these new menus to easily make new dots-related scripts. Create a new unmanaged system. That system will need to have access to the physics world to perform the raycast. You can access it as a singleton using the system API. This singleton is maintained by the physics system. So we need to run our system after the singleton is updated. Otherwise, we would get the physics world from the previous frame. To do that, we can use two attributes. One to tell the system to update in the fixed step simulation system group, and another to tell it to run after the physics system group. The update after attribute will be ignored if the system we specify to run after is not part of the same group as our system. The update before attribute also exists to specify to update a system before another. Now we can create a for each statement to consume our inputs. We can use the physics world to cast our ray and collect the closest hit. And if we have a hit, we can log the hit position in the console. Finally, we clear the input buffer to avoid printing the message again on the next frame if the user did not click again. Go back to Unity to test it. As you can see, when we click outside the plane, we just get the input manager log. And when we click on the plane, we have both. And the position of the raycast is on the physics plane, not on the far clip plane of the camera. We are almost there. All we did now is a reference to a tower prefab to create it at the click position. But before that, if you enjoyed my content, please hit the like button. It helps to spread that knowledge to anyone who wants to make games. Thank you! I want the player to be able to create different kinds of towers. So I'll make a cylinder prefab and a capsule prefab. Now we need a way to convert this prefab into entities and tell which one to create. Runtime conversion of prefab into entities is not possible. Instead, we will define a new singleton entity with a list of prefab entity towers. Singleton entity are entities or components that only exist in one exemplary. There is no particular way to define a singleton. The simple fact that there is only one component of the type makes it a singleton. We can make a new authoring component that will have a list of prefab tower game objects. Then we bake that authoring component into a dynamic buffer of entities. Having only one instance of this authoring component in all our subscenes will make it a singleton. We can then query that singleton in our input system to select which tower to place. If there were more than one entity with the component specified in the getSingleton method, it would result in an error. Same thing would happen if we tried to set the singleton value using the setSingleton method. Let's place our tower on the terrain and expose the tower index to place in the editor through the input. Now in Unity, make a new subscene. It will contain all your singleton entity and avoid mixing them with other entities. Add an empty with the authoring component and populate it with the tower prefabs. We can now enter play mode to test it. Clicking on the plane will place a tower at the cursor position, and updating the index in the input manager will change the tower being placed. The way this is set up, we can place multiple towers in the same place. We can fix that in the next video and start working on the combat mechanics. Thank you for watching. I hope you enjoyed this content. If so, like and share to help me spread this knowledge. And if you have any feedback or questions, let me know in the comments or on Discord. See you in the next video.